You've seen this statue 1,000 times in photos. Arms out wide, standing perfectly calm over Rio de Janeiro, like it just grew out of the mountain itself. Except it shouldn't be standing there at all. 1,000 tons of reinforced concrete, balanced 2,300 feet up, on a peak where the wind can blow past at over 120 miles an hour. This isn't just a monument people take selfies with. It's one of the riskiest engineering bets of the 20th century, and almost nobody knows how close it came to falling apart before it even got built. Rewind to 1921. Brazil's about to hit its 100-year mark since independence, and the government wants a landmark that actually means something. Mount Corcovado gets picked fast. Great view, dramatic shape, sits right over the city, but it's also a lonely granite spike buried in rainforest, getting hammered by Atlantic storms on a regular basis. Before anyone even sketched a design, the location alone was already a logistical mess. The engineer who took the job, Heitor da Silva Costa, didn't start with the design we know today. His first version had Christ holding a cross in one hand and a globe in the other. It flopped hard. People mocked it so relentlessly that it earned the nickname Christ with the soccer ball. Rough moment for him, honestly. But that failure is what pushed him towards something sharper. Why not make the statue itself the cross? No prop needed. Arms stretched out. Art Deco style, sleek and modern for its era. Great idea on paper, terrible idea structurally. Because now he's got a giant cross-shaped building that has to survive wind gusts strong enough to tear a roof off. Back then, the obvious material would have been steel. That's what built the Eiffel Tower after all. Silva Costa went the other way, reinforced concrete, and people thought he was nuts for it. Steel out in that salty coastal air would have corroded within a few decades. No way around it. Concrete was still the new kid on the block, being called the artificial stone of the future, but nobody had ever tried anything this ambitious with it, let alone this high up, to make sure the whole thing wouldn't come crashing down. He brought in Albert Coquot, one of France's best structural engineers. Coquot's real headache wasn't the weight, though that alone was over 1,100 tons. It was the wind. Those open arms basically function like a giant sail. During a storm, the pressure pushing against that structure can hit hundreds of pounds per square foot. Concrete gave them the strength to handle it, but created a whole new problem. How do you pour concrete evenly, with zero air bubbles, at 2,300 feet? Where the weather can completely flip in 10 minutes. While the engineering side got sorted out in Brazil, the artistic side was happening across the ocean, in a studio outside Paris. Silva Costa knew concrete needed a real artist hand behind it, or the whole thing would just look like a slab. He brought in sculptor Paul Landowski, who built full-scale plaster models. The head alone came out over 12 feet tall, each hand passed 10 feet across. Those models got sliced into dozens of sections, turned into molds, and shipped over to Rio, where workers packed them with concrete right there on the mountainside. It was, without exaggeration, the largest three-dimensional puzzle anyone had ever put together. One numbered piece off by a few millimeters near the base, and you'd end up with a misalignment of several feet by the time you reached the top. Now think about what the actual job site looked like in 1926. No roads went up there. Everything. Sand, cement, water, scaffolding, those huge plaster pieces from Paris, had to ride up on a small rack railway that had been built decades earlier. There was barely enough flat ground at the summit to store anything, so whatever showed up that morning basically had to be poured or assembled before dark. Crews worked half-blind in the clouds a lot of the time, scaffolding turning slick and nearly invisible in the fog. No modern harnesses, no safety net, and somehow, across 9 years of construction, they didn't lose a single worker. Say what you want about the era, but that's close to a miracle. People assume the statue is just a solid block of stone. It isn't, not even close. Underneath that surface, it's basically a hollow 12-story building, held together by a web of angled beams funneling all that weight straight down into the granite bedrock. There's a staircase running the whole way up, from the feet into the arms and head, tight enough that you wouldn't want to be claustrophobic in there, and around what would be the fourth floor, right about chest height. There's something almost nobody knows exists, a small heart-shaped chamber Silva Costa had built into the frame, finished just as carefully as the parts everyone can see. even though it's the one detail no one on the ground will ever lay eyes on. Concrete's tough, but it's porous, and it cracks under heat over time. Silva Costa needed a surface that could take decades of that kind of punishment. He found it in soapstone, quarried out of Minas Gerais, soft enough to carve like chalk, but it hardens up and turns nearly waterproof once it's out in the elements. The problem was covering something this curved and complicated with actual stone. The workaround they landed on was wild. The stone got cut into roughly 6 million tiny triangles, a little over an inch across. Instead of setting each one by hand, thousands of women from local parishes glued the pieces onto sheets of paper, which got carried up the mountain and pressed straight into the wet cement, almost like wallpapering the whole statue. A lot of those women wrote names on the back before they disappeared into the structure forever. Husbands, kids, wishes nobody would ever read. Being the tallest thing for miles on an exposed peak also makes you a lightning rod. Literally, storm season at Corcovado gets brutal, so the entire frame was built to act like a Faraday cage, with rods worked into the crown and fingertips, sending strikes down through the metal skeleton and into solid rock. Even with all that, the stone itself doesn't always survive contact. In 2014, a strike blew the right thumb off completely. Fixing it meant sending climbers rappelling down from the head, out along the open arm, to rebuild the tip using soapstone that had been set aside from the original 1930s quarry, kept in storage for exactly this kind of emergency. On October 12, 1931, the lights went on for the first time, and what people saw wasn't quite art and wasn't quite engineering. It was both, fused into one thing. A 1,000-ton figure that somehow reads as weightless, thanks to clean Art Deco lines and joinery measured down to the millimeter. 9 years of work, millions of hand-set stones, a vision that turned an unreachable mountaintop into one of the most recognized silhouettes on the planet. So next time you look at Christ the Redeemer, remember what's under that stone's skin: concrete and steel that pushed the limits of what people thought buildings could survive. Because real engineering was never just about the numbers. It's about being willing to dream straight up into the sky. If stuff like this, the hidden engineering behind the world's biggest landmarks, is your thing, hit subscribe. There's a lot more of this coming.